So here's my presentation about microclimate measurement in subtropical cities, systematic review and proposed guidelines. I am Zhixin. I am now a postdoc fellow at the Chinese University of Hong Kong. 2 months ago, I published a guideline paper collaborating with Bob, Professor Jin, Professor Ng, and my colleagues. So today's presentation will be based on this paper. I will start with the global warming and intensive urbanization. So as we know, now many cities suffer from the urban heat island effect with severe heat stress for residents. So to cool the cities and improve human thermal comfort, research on microclimate has been widely conducted. The importance of urban microclimate has been emphasized by many organizations and governments worldwide. For example, in Hong Kong, the Green Building Council, they published a guidebook to talk about the urban climate study, and the London Authority, they offered a wind microclimate guideline for better air ventilation in the City of London. And also, here's a handbook about microclimate from the UK Met Office. So we can find that more and more people, including government and the researchers, have realized the significance of incorporating microclimate in urban designs. In terms of the microclimate, so have you thought about how many ways we can use to study the urban microclimate? So for this question, actually TRO has answered in his book, Urban Climate. He has summarized the 4 common approaches in the urban climatology, that is the field observations, physical modeling, numerical modeling, and empirical models. So now let's talk about it one by one. The field observations relies on measurement of surface and atmospheric properties using sensors. And for the physical modeling, researchers usually use the build scale models. So for example, this is an urban model from my research team, and this photo is about a famous Japanese scale model experiment. And for the numerical modeling, I believe that all of you are very familiar with it, such as the MVMAT is a very famous numerical modeling tool. By using the numerical modeling, it can help us answer the what-if question. So for example, what if we change the material for the buildings? What if we change the pavement? What if we plant a tree here? And what if we change the tree species here? So we can turn things on and off and see what happens. And for the empirical models, usually it looks like a regression model like this. And in Oak's book, Urban Climate, he has summarized the advantages and the disadvantages of each method. And we can find that the field observation can provide the most direct evidence of microclimate condition in reality, portraying reliable results as the first-hand information. And although numerical modeling is another widely used research approach, the field measurement data are indispensable in model validation and calibration. So now, we know how important field measurement is, but I have to say field measurement contains many details that would influence the accuracy of measurement results. And our landscape student may not have enough experience in how to select the instrument, how to select the field site, and how to respond to unexpected conditions. So therefore, we need a guideline to tell us how to conduct a proper microclimate field measurement. There are some guidelines, standards, and handbooks have been published to clarify and standardize the measurement process. For example, this one, guide to instrument and method of observation. This is the most famous guideline, and we also call it the WMO number 8 guideline, and it first published 70 years ago. It served to standardize the meteorological measurement. And here's a book from two Japanese meteorologists. They published this book and introduced their experience in instrument use, data collection, and the related field method. And the TRO have developed a guidance. In this guidance, he tries to tell people how to set a climate station in a complex urban environment. And also ISO developed some standards. For example, this one, the ISO 7726, and this one, ISO 7730, are usually mentioned in many field measurement papers. And also, SHARE also published a handbook about the field observation. Despite existing guidelines and standards about meteorological observations, but when it comes to the microclimate field measurement in the urban environment, I think there are three issues remains. First is about the application scale. Currently, the previous meteorological observation guidelines are for standard climate stations, and they focus on the local scales, but avoid the microclimate effect. And some standards are initially developed for indoor or working thermal environment, such as the ISO 7726 standard and the SHARE handbook. And the other thing is about the application location. As we already know, the urban microclimate is a complex system. It is strongly affected by high-rise buildings, narrow street canyons, changeable and anthropogenic heat and cooling, and complex human activities, etc. So therefore, we need a guideline includes the considerations of the complex urban environment. And another point is about the systematic workflow. We found that some existing guidance, they mainly focused on the equipment instructions, but few of them mentioned the experimental workflow, including the pre and the post-processing. So therefore, it is essential to provide the researchers a clear path to consider every detail in urban microclimate field measurement. This slide is about our approach to formulate the guidelines. We did a comprehensive and detailed literature review. We reviewed the last 5 years field measurement studies, and we try to summarize their experience, and we want to see if there anything can be done better in the future studies. And we also review existing standards and the guidelines. We try to recognize crucial issues that deserve reconsideration, and we want to extract the useful concept and method into our field measurement guidelines. So from the literature review, I found that many things can be done better in future climate field measurement. So my colleagues and I proposed a field measurement workflow and guidelines, and we suggest a 4-step workflow that is formulating field measurement plan, preparing for field measurement, and sustaining measurement quality on the test, and curating data. So for each steps, we list all the detailed hints, precautions, and recommendations that we thought are important and cannot be omitted. But today, because of the limit of time, so in this presentation, I will mainly introduce what we provided in the guideline paper, and I will not mention the small details here. Okay, the first section of this guideline is formulating field measurement plan. So the first thing we need to do is to establish clear measurement objectives, because a clear understanding of the research objective can facilitate the plan's realization. From the literature review, I found that there are two common used research objectives. One is to evaluate the outdoor thermal environment and its driving factors, and the other is to assess the outdoor thermal comfort condition and the thermal perception from both subjective and objective perspectives. And I also found that sometimes both research purposes may appear in the same study. So the first step is to clear your measurement objectives. And the second step is to determine the field measurement type. From Kia Oak's book, we can find that there are three kinds of field measurement. That is the fixed, mobile, and the flow following approaches. And I can tell you the fixed one is the most common used one, but it has high demand for instrument and manpower. So some researchers will use the mobile measurement. They will usually use strategy. That is a variant for the mobile approach called the stop and go. So it includes stops at a specific transect point to take the measurement. And for the flow following, this is also a special form of mobile measurement, and it usually uses balloons, bubbles, and colored gas or smoke. I have to say this kind of approach is not commonly used in microclimate field measurement, so I will not discuss this approach in my deadline paper. Okay, so the next step is to select and characterize the field study site. The first thing we need to focus on is the site representativeness. The result of the field observations can represent the range of urban areas, and so we call it site representativeness. So for example, as you can see in this photo, this is Mount Hong Kong, and its site dimensions can represent the surrounding neighborhood on a large scale because of the homogeneous urban form. So for this kind of urban form, there's no need to set many measurement sites. It is because when you set your site here, here, or there, the results are almost the same. And in contrast, a site in a hilly or coastal location, such as the Causeway Bay in Hong Kong, in this kind of area, only one or two measurement sites are unlikely to represent the zone's climate. So instead, a network of measurement sites is required to assess the spatial microclimate characteristics. And when we select the measurement site, the control variable method is the most common way to investigate the thermal effect of urban elements. So usually the researchers would like to use the LCV classification to help them select a specific urban form. And for some specific studies, additional criteria need to be considered. So for example, if you want to conduct a questionnaire survey in your study, I suggest you considering the visible and accessible to most participants. And if your study will focus on the trees, I will suggest you avoiding surrounding thermal influence on your sample tree. Another 2 point is that please consider the availability of permitted space and electrical power. And the other thing is about the field trip. This is very important and cannot be omitted because it is impossible to fully understand the site conditions in detail from digital maps or satellite images. So for example, from the Google map, this place is under construction, and actually this shopping mall has been built. So if you don't take a field trip, you will miss this perfect measurement site with beautiful green roofs and vertical greenings. And another point, which is very important, is about the field site documentation and the metadata. I have to say in a paper, if we only describe the field site by their names, that is not enough. So for example, if I tell you I did field test in Bangkok, in Sunny Bay, in Shanxitu, and Jiangguan'ao, you will be confused. This name of places means nothing to our readers who are not familiar with Hong Kong or other cities. So for the site documentation and metadata, so our guideline provide a metadata checklist like this. From the WMO guidelines, the metadata means all the information or data about the measurement data. We call it metadata. And for this checklist, we refer to the WMO metadata standard and the review studies. So here we listed all the items that we think as important and provide their definitions. And we also apply Hong Kong as an example to show the metadata for local environment. So if you want to describe your city in your paper, so I would like to recommend this checklist for your reference. And moreover, it would be good to provide more quantitative information about the urban climate, such as the annual or monthly mean, maximum, or minimum air temperature and relative humidity. So, and as well as the wind rows. So in my guideline paper, I also use the data from Hong Kong Observatory to provide an example for the readers. And the next step is about the site characteristics. There are two kinds of information necessary to describe your field measurement site. One is site map and photos, and the qualitative and quantitative descriptions. So about the site map and photos, in my paper, I provided an example for your reference here. And in TROP's guideline, he suggests using an aerial photograph as the local scale map because it can furnish details of buildings and trees. And the site photos, and including the panoramic photos, it can provide a perspective view, supplementing details in the pedestrian level. And if you wanna give a view of the sky occlusion conditions, I will suggest you using the fisheye lens photos. For the qualitative descriptions, I suggest you referring to my metadata checklist. And for the quantitative descriptions, I would like to suggest you using the urban morphology parameters because it can be objectively compared and analyzed in assessing the thermal effect of different sites. And in my guideline paper, in its appendix B, I have summarized the frequently used urban morphology parameters in microclimate field observation studies. So there are several categories about the sky occlusion condition, the street canyon, the building, the urban greenery, the tree, the water, and the ground cover, and distance from the heat source. And you can find in this table, and I list all the parameters and their definition and calculation method here. And I really want you find it helpful. And for the urban morphology parameter calculation, you need to set the buffer size. So from literature review, we find that the buffer size in 10 meters, 20 meters, or 100, 200, 300, or 500, 700 meters were all used in previous studies. So for your study, I think a sensitivity test should be conducted because the suitable buffer size varies from research areas and your selected parameters. Okay, after introducing field size, so now let's talk about the microclimate variables and the instrument. So if you want to select an instrument to measure the air temperature and the humidity, PRO mentioned in his guideline that the sensors in general meteorological stations are all appropriate in urban areas, including their accuracy and response characteristics. But when you put your thermometer in an outdoor environment, you will find that the temperature and the humidity sensors may be heated by the radiation sources such as the sun and the surrounding warm urban surface. And under the extremely unfavorable conditions, the air temperature could be overestimated by up to 25 K. So therefore, radiation shield with proper ventilation should be applied to minimize the radiative exchange between the instrument and its surroundings. So here, I listed some points can be considered in selecting the thermometer and the radiation shield for your reference. And if you want to select an instrument to measure the wind speed and the direction, so you can see the photos in this slide. So there are various anemometers based on different techniques. And I think their selection mainly depends on the wind characteristics in the urban study areas. And for me, I would like to recommend the unidirectional or three-dimensional anemometer like this, because it can capture the turbulent flow in urban areas. But I have to say this kind of anemometer would be expensive. But if you want to choose the less expensive anemometers like these ones, please remember that these kind of anemometers are unidirectional or bidirectional. But we can use this kind of anemometers in the unidirectional flow situation, such as the Street Canyon. If you want to select the instrument for some radiation-related variables, most researchers will use TMRT, that is the mean radiant temperature, to investigate the radiative exchange between the human body and the surrounding environment. And the various methods for estimating TMRT has been reported in ISO 7726 standard, and I suggest you to look at it. And generally speaking, the six-directional technology is the most accurate method. But however, it needs 3 pairs of hydrometer and a pyranometer. So that means that method would be very expensive. And if the budget allows, I will recommend this method. Alternatively, you can use the global temperature to estimate TMRT. And from the literature review, we find that a medium gray color globe with a 38 to 40 millimeter diameter is this kind of globe is recommended like this. And in terms of the surface temperature measurement, there are 2 ways. One is contact, another is non-contact approach. I have summarized their advantages and their limitations, and you can find this table in my guideline paper. And in my opinion, I would like to recommend the thermocouple because it is accurate and less expensive. But please remember that the thermocouple needs a data logger to save the data. And in general, a data logger needs electrical power and battery, so you need to consider this point. And for the thermal image camera and the temp gun, I believe you are familiar with it. because it's widely used during the COVID-19 pandemic. This kind of instruments are easy to use, but if you want to get an accurate result, you need to know the long wave emissivity of the object. Once the measuring variables and their corresponding instruments are determined, the instrument metadata should be documented in detail. So here is the metadata checklist of the instrument for your reference, and you can find it in my paper. The next step is to picking the reference station. As you can see in this photo, this is the field site and the reference site in my previous experiment. So by comparing the differences from the tree shading area and the nearby open area, we will know the thermal effect of this mango tree. And the next step is to choose the field day weather. From the literature review, I found that most researchers would like to conduct their field measurement on a sunny days or clear sky days, because it can avoid the effect from cloud cover and the participation. And in some cities such as Hong Kong, Guangzhou, or Taipei, the cloudy days are more useful than the clear sky days in summer. So in some cities, they will use the partly cloudy days to do the field measurement. And some researchers will use the so-called typical summer days or representative days. For example, Professor Jim selected the typical summer sunny day in Hong Kong as the day with 700 watts per square meters of average daytime solar radiation and no or little rainfall. And I have to say, for this kind of weather condition, threshold criterion can need to be applied because based on the local weather data. In my opinion, since the questionnaire survey and the microclimate measurement may be conducted at a different urban site and repeated several times, so a common weather type should be chosen to minimize the variations among observation days. And the next step is to select a field date and the time. So from the literature review, I found that in general, researchers will use the extreme conditions, i.e. the hottest part of the day, that is around 3 p.m. and the strongest incoming solar radiation of the day from 12 to 13 o'clock. And for some human thermal comfort studies, the research objectives outdoor activity time should be considered. So for this, I would like to recommend this paper from my previous research team. The researcher conducted surveys about the main activity time in each season and shows that the residents tend to start the outdoor activities from about 3 p.m. in summer. So in this section, I talk about formulating field measurement plan, and I introduce how to clear your measurement objectives, how to determine your field measurement type, and we also talk about the field study site, the microclimate variables and instrument. I also introduce how to choose the field day weather, date, and time. And the second section is about preparing for field measurement. One of the important things is about instrument calibration. There are two ways of calibration. One is under controlled conditions. That means you can use the climate chamber or liquid bath, The other method is build a test in the actual environment. As you can see this photo, this is my instrument calibration last summer in Hong Kong. And I will not introduce the details about calibration because you can find the specific detailed calibration procedures in the WMO number 8 guidelines here. And another important thing is maintaining the instrument. You need to keep your instrument clean. It is because the dust and the particle in the air may reduce the sensor sensitivity and the measurement accuracy. So for example, if there are some dust on the glass dome of your pyranometer, it will affect the measured solar radiation. And the dust and the particle will also damage the moving part of the mechanical anemometers. It will damage their cup and their vane. And then the other important thing is you need to store your instrument in shaded and dry locations and check your instrument regularly. So the next step is to develop a weather monitoring system. There are two ways. One is you can use the commercial all-in-one weather station. For example, this is the Watchdog weather station, but it may not meet your own requirement, so you can use your self-developed weather monitoring system. And regardless of the type of the weather station, we usually mounted the instrument at the height of 1.1 meters to 2 meters because we want to focus on the microclimate at the pedestrian level. And in some human biometeorology related study, a height of 0.6 meters is also applied to represent a sitting person. And for the mobile measurement, there are various kind of monitoring systems, as you can see the illustration here. This is a self-developed mobile measurement system in Bob's team, and these are two photos about the backpack and the vehicle monitoring system in my current research team. And here are some points I wanna tell you. First is using a bicycle or walking is more flexible. And the other thing is please remember to keep enough distance between the operator and the sensors to avoid obstructing solar and terrestrial radiation and wind. And the other thing is I suggest you using GPS because it can help you record the location and the time data. The other 2 points is about recruiting and training student helpers. It will take some time, and you need to seeking permission for site access and use. For ask for permission, I think this is a very important thing. I can tell a story for you. That is a sad story from my colleagues. So this summer, my colleagues plan to conduct a field test in public estate in Hong Kong. So she needs to get the permission from the building department. But it took her more than 1 month to wait for the response from the government. And finally, she got the permission in the end of July. But at that time, half of the summer has passed. So that's quite a sad story. So I want to say, if you plan to conduct a measurement in public space, and if you need to ask for permission from the government, I suggest you contacting them as early as possible. And the next step is to check the weather forecast, and you can prepare some accessories. Here I listed some accessories that I think are very helpful and useful based on my own experience, and you can find you can find them in my guideline paper. And before you conduct the field measurement, don't forget to set your instrument to synchronize the clocks of your instrument to set the unit to check the power remain in the instrument. And a preliminary test is also an important point because it can be regarded as a rehearsal for the live measurement. So in this section, I talk about preparing for field measurement, and I introduced the instrument calibration, maintaining, and I talk about how to develop a weather monitoring system and how to organize a field measurement. And the third section is about sustaining measurement quality on the test. Please remember to check the equipment and the data storage regularly. After starting the measurement, I think all the equipment should be checked at least every 2 hours. And if there's no built-in automatic data saving in your instrument, the saved data should be checked hourly or more frequently. And the other important point is about the observation log. I think it is important, but the field study mentioned this. So we listed several essential points that should be included in the log, and you can find them in the guideline paper. Let's talk about how to respond to unexpected conditions. For the natural inference, I think the unexpected precipitation is one of the most terrible things. So if the rain is about to fall, please remember to use the waterproof clothes. And whether the field measurement data can be used, it is depend on your research aim. The other point about the unexpected condition is the human disturbance. Because the pedestrians are quite curious about the instrument, but if they stand too close to the instrument, they may block the incoming solar radiation and the wind, and cause the measurement uncertainty. So we need to keep them away from the instrument, and I think this 0.5 meters is quite enough. The other thing is, don't forget to collect the local meteorological data of the field day in time, because it is very useful in your future data analysis. So in this section, we talk about the sustaining measurement in quality on the test. And the last section, I will talk about curating data. So about the data processing, I would like to provide 2 examples. So when you calculate the TMRT, please remember that the diameter of globe is in meters, not millimeters. And there has been some recalibration method that you can choose in your TMRT estimation. And I would like to recommend this paper because it has summarized all the methods you can choose in your study. Some researchers would like to use the human thermal comfort index in their study, and the PET, SET, UTPI, and the COMFA model are the most common used ones. And in my opinion, I would like to recommend the COMFA because COMFA can describe the heat flows of energy to and from a person in detail. And please remember to elaborate the reasons for choosing your index, and I would like to recommend this review paper, and because this paper has summarized the characteristics of all the human thermal comfort index. So, okay, here is all the information I would like to present today. I hope you find this guideline paper helpful to your field test. And I really hope that you can read the guideline paper after today's seminar. For the future study, I would like to provide one direction. I think the standardized questionnaire design in human thermal comfort research can be another valuable direction for microclimate field measurement guidelines. And for me, I didn't mention this in my guideline because this is another big topic, but I really hope that someone can propose a guideline in this direction, and I am quite sure it will be an important paper. So, okay, here is the last slide for my presentation. I want to say learning from current guidelines and standards and the field measurement studies is important. And I hope that in the future, more and more students, researchers, and the professionals can record and share their own precautions, their own experience. And the microclimate field measurement should be systematic and standardized. So that's all. Here's all my presentation. Thanks for your attention.